Here we have the sum of an infinite geometric series. And on the infinite geometric series, if you look at the sigma notation here, you've got a times r raised to the k minus 1 power. They say that this converges if and only if the absolute value of r is less than 1. So if your r, your common ratio, is a fraction or a decimal between 0 and 1, then you are going to say that it converges. If it does converge, then the way we're going to find the sum is by taking your a and dividing it by 1 minus r, your common ratio. Okay, so we're going to look to see if these examples here converge, and if they do, then we're going to find the sum. So looking at the first one, if you take your fouling term, which is, we'll pick 1/16, you divide it by your previous term, which is 1/48, that's the same thing as 1/16 times the reciprocal, which is 48 over 1. Well, 48 over 16, that reduces to be 3. So here our r is 3. When you take the absolute value of 3 and compare it to 1, 3 is not less than 1. That's false. So this diverges. It does not go to one limit or one number. Okay, if we look at our next example, the next example, you have the sigma notation here going from 1 to infinity. And then you have 5 times the quantity of 2/3 raised to the n power. Okay, we need to first start by looking for our r. And the way this is written, what's attached to your exponent of n, this is your r. So r is 2/3. Well, if you take the absolute value of 2/3 and compare it to your 1, 2/3 is less than 1. This is true, so it converges. Okay, so we need to find our a. So we're going to take our, we're going to look at a sub 1, plugging in 1 for n. It's going to be 5 times 2/3 to the first power, and 5 times 2/3 is 10/3. Using that formula, they said take your a, so we have 10/3, and divide it by 1 minus r, and r was 2/3. Okay, so now we need to work this out algebraically. This comes out to be 10/3 over 3/3 minus 2/3, because you have to get common denominators, or 10/3 over 1/3, or 10/3 divided by 1/3 or multiplied by the reciprocal, which is 3 over 1. Your 3's will cancel, and our sum here comes out to be 10. Okay, go ahead and pause the video and try the problem at the bottom, and then unpause the video and see if you've done the work correctly here. Okay, this concludes the video for sum of an infinite geometric series.